So my name is Sri Ilaprolu. I am a solutions architecture manager at AWS. And so what I wanted to do is get the session kicked off. The purpose of this session is to introduce you to how AWS is helping and how IoT is being implemented in terms of doing smart infrastructure and smart city-based projects. A couple of guests that I'm going to invite up here. Both of the guests are from US State Department, so they'll actually go into a lot more detail as to what it is that they're doing, what are some benefits that they expect to get out of the system, and give you a scope as far as what the breadth and depth of this session is going to be, as well as their implementation in the project. So without any further ado, I would like to invite Landon.
You have a clicker?
Sorry.
Do you have a clicker?
Yeah, sorry. Landon is a senior advisor with US State Department.
Yeah. Hello. Hi. I guess I'm going to jump on stage. How's everybody doing this morning? Can you hear me? I can hear myself. I love morning speeches because everybody is doped up on coffee and donuts. So I'm looking forward to some great energy and excitement here. So the State Department, so my job at the State Department, just to give you a quick background, is I'm the senior advisor on energy, environment, sustainability for our operations. So we look at everything that we do around the world and we try to make it better, all right? And we try to reduce our footprint at the same time. What we were looking at for what we call MeterNet, and this is why we're here for smart cities, is we were looking to try to actually fulfill one of our executive orders that basically said we needed to put advanced meters on any federal building that we own. And we said, okay, well, we have quite a few federal buildings, but we wanted to figure out how we could network them all together. And so we came up with what we call MeterNet. Now, let me give you a little background about the State Department here. Our initial scope, we're in about 190 countries around the world. We have about 22,000 buildings that we actually oversee. We have, let's see here, about 65,000 employees around the world, and about 2,000 of these buildings are highly energy intensive, and it would be helpful for us to have smart meters on those buildings so we can see what they're doing and see if there's better ways to run them, all right? But understand that we have a huge security scope as well. We obviously have embassies, which we don't want. We have security envelopes around them that we don't want to have be infected. So basically, we looked around the world and we said, okay, well, how are we looking at the utility information we're doing now, which was we were collecting it manually. We wanted to shift that to automation. And at the same time, we needed a system that was really cheap and affordable and usable to everybody in the field. So let's see here. This was our typical system that we ran, if we ran it at all, is we would collect utility information and we'd stick it in a database. And sometimes we would get an engineer to take a look at the information and they would try to make sense of the information and give us advice and perhaps do an audit on a building and say, oh, this building is spending way too much energy, but we didn't really know why. But that's how we basically did it. We got data into a database, we kind of looked at the information, and then sometimes we created a report. The reports basically had limited usefulness because we didn't have enough granularity in the data. And we had manual entry, so many times we would look at something and we'd say, is that right? We spent $20,000 every month this year, except for this one, which says that we had $260,000. Now, we sit back and we go, well, that could actually be accurate because in some countries, they bill you a lot on one of your months and not for the rest of them. And we have, again, we're in 273 cities or 274 cities. So we're dealing with at least 200 plus utility companies and their billing system's always different. And so for us to actually evaluate this information and make sense of it was quite arduous, especially if it was manual entry. It wasn't granular enough. I don't know if anybody comes from Germany, but in Germany, our utility bill comes once a year. So if you want to know how you're doing on progress, let's say you do a lighting retrofit, and you want to see how that lighting retrofit is affecting everything over the next couple of months, you have to wait till next year. And then hopefully, you'll see a drop in the overall consumption from the last year to this year. So it wasn't granular enough, and we had a lot of entry gaps. You know, we have facility managers and we have people out in the field. They're doing a lot of very important things throughout the day. They really don't have time to be putting in utility information into a database, which for them, they don't see any value. I mean, they're not actually doing the evaluation, and if information does come out and says, oh, this would be useful, we have an engineering team that would go out and actually help them. So there was less value there for the end user. So we looked at using the smart meter. Basically, with the smart meter adding to the database, we were able to add a few things. We basically were able to automate all the information coming in. We were able to make it constant, so we didn't have any gaps. Obviously, meters are a little bit more accurate than manual entry. We're actually able to verify what was going on with the utility bills as well, so that was kind of nice for us. And it was granular enough for us to observe what was going on in the building. We were doing it at least 15 minutes a day, all right? Understand that we started domestically first at some of our buildings here. Across the street from our headquarters over on C Street, we have a building, we call it SA1. Essentially, that building, just to give you an example, we put these meters on that building, and within the first week, we noticed we were getting spikes every 15 minutes from our machinery in the building. And we're like, well, okay, that's interesting. What does that mean? We tracked it down. We found out that all of the air handlers that run the air through the vents were turning on every 5 minutes. And they were turning on and off every 5 minutes because the $8 thermometer on the roof was broken, and that thermometer tells the computer to use outdoor air or indoor air. That saves us about $50,000 a month by having that one $8 thermometer fixed, which we would never have been able to identify had we not had the granularity in the meters. So that can give you an idea of the potential that we can do with our embassies around the world. Understand, we spend about $500 million on utility costs every year, okay? So it's a lot of water, it's a lot of diesel, it's a lot of electricity. With smart meters information going into the database, we then still had energy analysts take a look at the information and provide more actionable reports. Because it was more granular, we were able to find out, hey, these buildings probably, they need to have their set points changed. It looks like people are coming into the building way later than what you're actually starting to chill the building at. Maybe you should start chilling it at a different time frame. Or maybe you should shut down the building's HVAC unit at a different time frame. Sometimes you see spikes and you realize that there's equipment failures about to happen. All of that becomes actionable items for us to work with our embassies and say, hey, we've spotted something, let's see if we can fix it. All right. This was MeterNet 1.0, and because of it, we had a lot of great benefits. Number one, we met our domestic requirements to put advanced meters into our buildings. We did gain near real-time metrics, so we were able to identify more problems for our buildings. Obviously, by reducing manual collection, we actually freed up a full-time employee to do other things. Obviously, we've identified areas we can improve. We were able to do recommendations for the field, but we did have some drawbacks. This had very limited scalability and very limited access. And the reason is because we put these meters on our internal network, okay? So we were using our internal network to transfer all of this information to a database, which of course is in our internal data center, which then has limitations on who can access that data center. And so I have a project over in Managua where I have an energy saving performance contract, and we have a vendor would like to verify that all of the work they did at that embassy is accurate and performing. They don't have access to that database, even though that database is collecting everything that they would need, because it's in our internal network. So for us, accessibility became a key question, all right? And of course, scalability. Understand that with this alone, we have already seen, on average, about $35,000 in cost avoidance for energy use at our embassies. We identified cost avoidance of about $35,000 annually for every post that has it. Understand, we want to put about this structure in about 200 of our embassies, all right? Which on an annual basis is about $7 million. So we look to see what we can do just with this alone, but we recognized that electricity was not the only thing that we were spending money on. So we needed to be able to expand the system, look at gas and water. So because of success, you end up with MeterNet 2.0. Basically, we had a brand new set of challenges that we had to look at. We had to enable the scalability. We needed to make sure everybody in the field could have access to this information, that they needed it. We clearly, by having more meters out there, sending information to a location, we were opening up more attack vectors for anybody else that would like to actually get into our network. And we recognized that. So that was one of the problems that we were trying to figure out. How do you remove additional attack vectors at the same time you increase accessibility to people out in the field, and you expand your metering and your sensoring system around the world? Obviously, having a human analyst create reports can be expensive. And because we were trying to scale up, we recognized that, number one, if we had 200 embassies running at the same time, we would need a lot of engineers looking at these analytics and providing advice. Moreover, many of our facility managers only have time maybe once every blue moon for 2 weeks when they're free. And they can actually sit down and go, all right, I heard that we have some recommendations to take care of. Let's take a look at them. And they want to have the most up-to-date information and the most up-to-date recommendations, right? But they might only have 2 weeks to actually get them done. And we can't predict when that's going to happen. So we needed to have something that's more instantaneous for the people in the field, basic recommendations, and still reserve the engineers we do have to really do a deeper dive on the information and provide some deep retrofit recommendations down the road. Of course, we also wanted to integrate other data sources. So once you start getting people excited about, hey, this is what the system can do, more people come out of the woodwork and they're saying, hey, can you get us more real property information on this? Could you tell me what the square footage is, the cost for square footage for electricity, or for water, or for gas? They want to know all of this stuff. And so your success of saying, hey, we're able to save this money, made people think, well, you can maybe save our group of some money too. And so more people wanted to integrate their data sources. And then, of course, our engineers can never be satisfied. They always come back and say, well, the next big widget of meters is this, and we want that awesome meter out there rather than the basic one that you guys put in. And so we had to figure out how to future-proof the technology to accept new advanced meters as they come online, as they come out of the manufacturer. So taking a look at what we had before, our smart meter goes into our internal database, and then we have an analyst read it, they create reports. We took a look at that and we said, okay, what do we need to do? Well, we need to add real property databases and financial data streams into the system. We actually have a huge portion of our homes, our employees. Remember, I said 65,000 employees. A lot of those are residential homes that we manage. We want to be able to see what's going on with those homes as well, because in many countries, you actually have electricity theft, right? So we're paying these huge bills, and we're not understanding why our employee is spending $20,000 on electricity every month. Well, it's probably because the rest of the neighborhood is actually attached to that employee's electrical line, and it is also taking electricity out. So we needed to actually have residential meters as well. Building automation. This is really where our gold mine of sensors and data points are. Understand that building automation is great. Getting all of that information, understanding what the air handlers are doing, understanding what your chillers are doing, but it also has the opportunity to be misused. If someone can access your building automation system, they can take over your building automation system. And so we had a security question that we had to face. And we also recognize in countries like the UK, in London, for example, they have a mandatory requirement by law that every building in London has an advanced meter. So we kind of question, well, why would we spend the money to put meters in buildings when the utility company has that information already? So is there a way that we could actually access the utility company's database, have that information sent to us so we can analyze it and then improve our own building consumption? So that was another feed that we were trying to figure out what to do with. Understand that our internal database, as wonderful as it is, it was an on-premise server, and because it was on-premise, it had limitations. It had security limitations, accessibility limitations, and our IT people were screaming at us going, what about the bandwidth? What about the bandwidth? We have a private network. We don't want you stealing all of the bandwidth trying to bring back all the censored information, okay? So we said, okay, well, what if we weren't on-premise? What if we did something else? And this is where we ended up looking over at the cloud. And so looking at the cloud, we recognized, all right, we could actually send all of these data feeds to one source in the cloud, which of course has different hops around the world. So it has its own routing system around the world. It'll be able to jump around a little bit faster than just going through our internal routers. It would have innate security features because all of the clouds that we would be using have their own screening and deep packet review of data as it gets transferred through. And we recognized that utility companies could actually send their information. They batch information to certain cloud vendors right now anyway. So there's that capability already built in. And so rather than it going to our data center, we decided to have it go to somebody else's. And of course, within that data center, we're able to obviously do data analytics. We're able to do internal reporting. We have the power of computing, or cloud computing. So rather than wait for a couple of weeks and build up a bunch of servers so we can do the powerful analytics we want, we have cloud computing, which can just be flexible and do it right away for us. We have the ability to have web-based applications, so we can do interfacing. So anybody around the world, if they have the right credentials, can access this information, which means my people down in Managua can actually do their verification. People around the world that are doing other projects have the same ability. And the part that we really liked was the machine learning. All right, so we're working with C3. I believe it's IoT, C3. They have within our system some machine learning which will start predicting patterns of the electrical points that we're starting to see. So we're hoping to learn a lot more about how our energy use is occurring around the world, and I won't steal too much from Hassan, who will talk a little bit more about that. But understand it gave us a lot more functionality to predict problems that might occur down the road, which is really useful for us, obviously. And because we get cloud computing, we also get automated reports. So we get this automated reporting. The information can still go to an analyst. The analyst can still review this information. But we also get this automatic generation of reports and recommendations. So our field should be very happy with that. So we get everything out of MeterNet 1.0 with our 2-point version. We basically get to bring all of our data information together. We have enhanced security because it's not, nobody's really trying to get into our system. You know, they have to get into that other system, which actually has a lot better engineers and architects looking at it on a constant basis and improving their security postures. We have obviously embedded analytics, machine learning, and the whole caboot. Oops, I hit the reverse button here. Hold on. So what did we gain? Okay, so when we were looking at smart cities, and that's actually what brought you guys in here, we were looking at the fact that if you look at a smart city, and we work with the DC government as well, and we exchange best practices and solutions, we recognize that almost any entity is looking for something that's cheap and affordable in the tech area, but it needs to be automated. It needs to be able to produce actionable reports, and they need to be automated as well. And you need to have a huge amount of security. Now, many city governments don't have those resources to actually apply to all of those things. State Department, we're a little bit fortunate. We have some wonderful engineers. But recognizing that we went for a cost-effective solution, which gave us way more capabilities, we were able to share that with cities as well and talk about how are we using this information. Because if you think about it, 22,000 buildings around the world on one sensor system, analyzing itself, trying to figure out how we can improve our functionality is very similar to a city. And many of the reasons why you don't see smart grid today within cities is the affordability and the security and the fact that even if you did gather all this information, you would not be able to analyze it quick enough to make actionable recommendations. And so the only way we could do that was actually move it into a cloud background. So with MeterNet 2.0, we do have future options. We have an enhanced security. We have both the historic and predictive analytics. And it allows us to actually, when I say increased accessibility, it allows us to actually engage our customers. So at the State Department, we think of our employees that are in their residence at their homes around the world as our customers. We need to be able to engage them, talk about what they're doing, educate them on how to improve the efficiency of their homes. We're paying for their energy bill, so it's in our best interest to do that. The same thing that a utility company would want to do or a city would want to do to engage its residents or its citizens, it would want to be able to talk about, well, how can we improve the infrastructure and the usability of the city, right? Because if you increase your energy demand of a city, you need to increase the infrastructure. And like I said before, many cities have a limited amount of resources. Utility companies have a limited amount of resources. So you need to enact a lot more efficiency into those opportunities for cities and for local governments. And the only way they can do that is that they're figuring out ways to engage their citizens. This gives us an opportunity to do that. And it does it in a secure way and provides wonderful analytics. And it's a wonderful way for a city to also look at ways to engage its citizens. So with that, thank you very much. And I'm going to hand it over to Sri.
Hassan will come up next, and he'll go into a little bit more detail as to what's actually under the hood and provide more insight. Thank you. That's awesome.
Oh, thanks, Landon. Thanks, Sri. My name is Hassan Green. I'm an electrical engineer with the State Department. I work in the Bureau of Overseas Buildings Operations. And I'm going to tell you a little bit today about our efforts to provide power quality monitoring via cloud-based infrastructure. So before I get started, I just wanted to say thanks to Landon for that introduction to the system, and also to our sponsors for putting this event together. So who we are, OBO manages the U.S. Department of State's building program. So basically we have operation and maintenance and disposal responsibilities for all of our overseas properties. And basically that mission requires that we provide safe and secure and functional facilities. And those facilities represent our government to the host nation. And we support our staff in the achievement of foreign policy objectives. So these buildings have to represent our values, and they have to have the best architecture, design, engineering, and technology. So what's our portfolio look like? As we said, there's over 275 locations. We have about 87 million square feet of owned and leased space. That works out with about 100 embassies, 90 or so consulates, and as was said before, the thousands of residential facilities. We operate basically in 190 countries around the world. There's a variety of systems and buildings. A few of the locations we have: Embassy in Rome, Consulate General in Barcelona, representational properties which are somewhat historically significant and also some very large housing buildings. So now we'll get into a little bit of the power quality issues. As you saw, we have facilities in basically every time zone, every geographic climate zone. And right now, because of the distance, we have a limited visibility of what's happening. And so the picture is cloudy. So we have to identify what is happening out there, and that requires monitoring, tracking, and troubleshooting. It's very good if you have an automated system that can help you with that. So MeterNet is our system that provides real-time automated data. And basically we use that data with our facility managers to find problems and fix them. In addition to finding problems and fixing them, we also provide energy consumption monitoring, and we're able to improve the efficiencies of our operations. Specifically for the smart meters, there are a lot of places where we operate that have unstable power grids. So we had to develop a tool that would allow us to leverage our technology while at the same time accepting some limitations in our manpower. So how'd we do it, or what's our plan? We had a phased process, and we started with the pilot, of course. And we started in 1 or 3 posts. It was based on volunteers. As the team rolled out the system, we got more people involved. And based on our original schedule, we were planning to have about 100 in posts by 2018. Right now, thanks to an extraordinary team, we're going to have about 150 connected by the end of this year. And we're still looking for the full 275 locations in the future. So the architecture is pretty straightforward. You have hardware overseas, you have a internet-based connectivity, and you have users. Basically, in the MeterNet 1.0, one user could look at one facility at a time. In MeterNet 2.0, we'll be able to identify multiple facilities simultaneously and also have simultaneous users, which allows us to do that troubleshooting a little bit faster. So how do we log in? This is the 1.0 version, but the 2.0 version is going to be very similar. It's a user-friendly portal, and it's role-based user access. Once you get inside, it's got a logical and intuitive format. You have benchmarks, you have a view of your overall system, and you have a few key performance indicators. It's very, very user-friendly and easy to understand. Like I said, I wasn't going to take that long. So the benefits. As we said, it saves a lot of costs and saves a lot of time. Right now, we only have a handful of engineers able to troubleshoot these millions of square feet of facilities. And also, the cost of operating these facilities can add up. And when you look at the total dollar value of 87 million square feet, you're working into the 40 or $50 billion range of property. So it's worthwhile to look at how we can operate that efficiently. Time saving. Our buildings are on the other side of the world. So the time it takes for me to send an engineer from here to there, there's probably new problems that I need to solve. And because we have to prioritize our work, this tool allows us to say, here's where we can focus on the analytics end, and we can focus our limited manpower to higher priority issues. We also have a mandate to continuously improve our processes. So by using this tool, we can identify trends as they're happening and also, provide warnings to our colleagues. Thank you.
Sam. So if I can actually ask Landon to join here up on stage, we'll have a few more minutes to take any questions you may have. Any questions? Yeah. Go ahead.
Microphone?
Yeah, thanks.
Thank you. Great case study. Appreciate it. Can you talk a little bit about the on-premises server side, the ETL server in that architecture? Just any general things about that? Is that a require a very specific footprint at each post, or is it kind of a little piece of software that runs on anything? And kind of how do you batch up or handle that ETL process, getting the meter data up into the cloud?
Part of that's actually. Can you still hear me? Am I on? Oh, okay. You're asking about how we get the information from the cloud, or from our internal server?
Yeah, from the on-post, in your architecture diagram, you showed an ETL server
Right.
on-post.
Yeah.
And then that pushes data up into the cloud. So
Right.
what is that ETL server? What's that entail? What requirements does it put on the post?
Oh, well,
So it's case by case.
yeah, it's case by case. Right now, we're using Niagara as our on-site server that collects all the metered information, converts it, makes it, digitizes it, and consumable. Then we have a security feature that makes sure it gets shot up to the right location. The information, what we have is legacy posts as well. We have people that are on our internal system, and we're slowly moving them off, but we still want to be able to put that information into the cloud as well. So we're anticipating a batch process where it will batch itself through a IPsec tunnel for temporary. Yeah.
Hello.
Yeah.
Can we get the mic turned on, please?
For the smart meters
Mm.
on
Yeah.
premises, were you able to get the utility companies to provide that information, or were you able to go in? So Pepco, for example, they now offer that. You could actually go on yourself and look at that. Were you able to do anything to get that information?
Yes. Yes. So the C3 Energy is the company we're working with in the cloud. They have agreements with various utility companies already to collect their information and to provide service to those utility companies. So it was fairly simple for us to have access to that. It'll be more challenging overseas because that's where the relationships need to get built. But that's diplomacy, and State Department's pretty good at that. So we're looking forward to that.
Hi. You had mentioned building automation as part of MeterNet 2.0. Could you talk a little bit about what is being done and how it's being isolated from the meters themselves and the internet in general?
Sure. I can speak in general terms because there is a little bit of sensitivity around that. But in general terms, there's a mirror server of what's going on in that building automation system. So the data points that we're pulling back are actually data points that are on a completely different server than the actual building automation system running the system at the building. And so we're pulling back mirror points, essentially.
There's someone back here.
Good morning. I have two unrelated questions. You mentioned the utility meters in London as already being smart meters and your desire to connect to them. Were you successful in that, and how were you able to do that?
It will be an agreement. Yeah, we have not yet. It's going to be an agreement with the utility company to have them batch that information to us.
They'll read it and they'll just batch the data to you.
Yeah.
You won't read the meter directly.
Right. Right.
My second question is, people in this country sometimes have privacy concerns with residential smart meters. Did you take privacy concerns or security concerns with the residential meters into account, and what aspects did you consider? Thank you.
Sure. Yes, we did. Understand that nobody really wants to feel as if they're being monitored And so part of it's an engagement process. You know, you need to actually come up with your own communication campaign, talking about what are the real benefits, both for the individual resident, but then for the greater good. And so for the greater good, it's the State Department. And so we do remind our employees that yes, we take care of their utility bills, but we also have to respond back to the Congress and show the Congress that we are both monitoring our consumption, we're working to engage our residents to help reduce that consumption as much as possible, and that we're being good stewards of the taxpayers' money. And so from that perspective, it's very easy for us to engage our employees and say, look, this is where we are, this is what we need to do. We'd like to continue to have a workforce that compensates its people in the appropriate way. And the only way we can do that is if we're showing that we're being responsible with the resources we have. So. I will point out that Hassan was very humble on the power quality monitoring, and I just want to go back to that because Hassan is a very humble person in general. I myself am very much of a braggart.
You want to go back?
And so when it talks about power quality, really he's looking at the energy harmonics from the grid. And we're looking for patterns of the harmonics in that grid because we're looking to see if we can actually start predicting with machine learning, are we going to have a blackout soon? If I'm in Bolivia, am I about to have a blackout? Have they shifted over something? Have they turned on a generator somewhere down in the grid? Are we able to identify what that pattern looks like ahead of time so we know we're about to get a surge of energy or a sag or something that might actually distort or shorten the lifespan of the equipment on our compound? That's what he's actually doing with the power quality monitoring. He's actually monitoring how effective the grid is, how effective we are at giving warnings to our facility managers. If we can predict we're about to get a blackout, we can have the system automatically, not us, but automatically with machine learning shoot off an email to the facility manager saying, hey, in about 40 minutes we predict you're going to have a blackout. Turn on the generators, right? So you have this ability to think down the road and actually be proactive with these new type of sensors. Another type of sensor that he's not talking about are some of the float sensors that we have for residential. As you were talking about residential, in many of the countries where we have U.S. staff, we have diesel generators running the electricity at those houses. And we have water tanks because the water is not safe enough for them to drink from the local city water. So we send out trucks on a daily basis to fill up these tanks. You know, we don't really know if those tanks are empty, do they need to be refilled, but we send out a diesel truck and we'll send out a water truck. And when it comes back, we hope that the trucks have the appropriate amount left in them and that they were only dropping off fuel and water at the appropriate tanks, and that they didn't spend the entire day as an employee just kind of driving around the city, right? With these sensors, dropping off fuel at my house. When we have these sensors, which are attached to the meters, so we have these sensors and they're attached to our meters, and our meters are sending it to the cloud, we're able to run the analytics and we can actually make predictions. Two things. We can have, number one, if I'm a facility guy, I wake up in the morning, I go in, I look at the chart and I'm like, okay, we have 5 houses that need refills. Everybody else, don't have to worry about it. Those 5 houses are located in these locations. It should probably take you about 2 hours to do. I expect you back here by noon, right? You have better ability to manage your people, number one. But then number two, you can also, you can use machine learning to observe what is the rate of depreciation of those tanks, which means you can actually start predicting when those tanks will need to get filled throughout the month, which means now you can start scheduling your employees to come in when you actually believe you're going to need them, right? So you have better management of your people, you have better management of your resources, and you have better auditing and recording and verification of what you bought and when it was used. That's what we're doing with those sensors, which Hassan, as humble as he is, didn't want to talk about.
We can talk about the sensors, or we can even talk about some of the issues when it comes to maintenance. You know, one of the nice things to be able to do if we ever connect to a BAS would be able to, you know, predict failures through the signals. If I have a motor that's maybe under speeding or over speeding, that'd be a good thing to know before my air handler failed. And hopefully we can do that through the cloud. Same thing with generators themselves. If I can connect sensors to my generator directly, you know, rather than waiting for the engine to seize, I can, you know, sense the temperature on the oil, know what its fuel burn rate is, and, you know, put in the proper work tickets. So
And
these are things
understand
we'd
that
like to be able to do, but right now
he's,
we're building that infrastructure.
yeah, understand when he's talking about generators, so understand he's not talking about a small task. You know, each embassy has, you know, 2 to 4, maybe 7 generators. Some have, you know, tens of generators on compound running. And what he's saying is we need to be able to understand if any one of those generators goes down, we need to know it before it happens so we can actually prevent that. We end up saving money when we're actually preventing a catastrophe rather than responding to one. And to be able to just say, oh, I noticed that this one generator is overheating. If you are looking at hundreds of generators, even Hassan, as great as he is, doesn't have the time to be looking at the screen all the time. So again, you're going to need automation. And you're going to need cloud computing to actually set trigger points to be able to notify people, and you set up a process map for a flow chart with emails and messaging to the right people to let them know this is what's about to happen. And you can put a critical on it because, you know, we have sensors that are basically saying this will happen.
Or even to go back to the utility and say, hey, we've seen this problem with your grid, and we have our data and we have your data, and now we want you to fix it, and here's what our engineers think you should do,
Right.
and give them a chance to respond. One of the nice things about having facilities in multiple places is you can actually see trends on the bulk power system, and then if you have access to the utilities bulk power data, which I think most folks are here, we're talking about the end user meter data, but having access to the bulk power grid operations would allow you to identify, well, was this power fluctuation, was it a grid event, or was it, you know, a local event? And so those are some of the things that are helpful when you're talking with the utility to say, hey, you guys had this problem, what are you doing about it?
I'll just ask really loud, I'll stand for it. Have the defense and intelligence communities come to you for access to this information as well?
Are you with the defense or intelligence community? I think it was actually kind of ironic that there's 4 lights, and I believe there are 4 lights, right above you,
Officially
which
stated in
basically
the
means I
policy.
can't actually see you at all. And you're like, yes, we are working closely with the intelligence community on the entire architecture and sharing our findings. So that's why I'm saying the sensitivity on some of the security envelopes, we're working with them as well. So.
Any last questions?